Alright, so today we're going to talk about phase diagrams. So, if we draw this, we have basics axis, or chart, with temperature on the x-axis and pressure on the y-axis. And they tend to have lines along it like this. And we'll pretend those are connected there. And what these do is they tell us based off of the pressure and temperature, what phase the substance will be in. So in here, we're going to have solids. Within this area here tends to be liquids. And down in this area here is our gas. All right. So to restate, right? So to reiterate, right? Phase diagrams tell us what state or phase a substance will be at a given temperature and pressure. So let's put another one up here. So temperature, pressure, boop. All right. So solids are within this area, and liquids are within this area. As we go from solid to liquid, reviewing, right, that is called melting. And I'm going to type that so that way you can actually read my writing. Right, melting. Oops. And going the other direction is freezing. All right, down here are gases. If we go from solid to gas, that's sublimation, and gas to solid is deposition. Liquid to gas is vaporization, and gas to liquid is condensation. So here's a much nicer one with all the definitions labeled and everything. Something I want to point out with them too is what's happening along the lines here, right? Because if if we're going at a single pressure and gaining temperature, the solid will eventually melt into liquid and then eventually vaporize into gas. But what happens to it right on the line here? What happens is that this substance is in equilibrium between the two states. So you'll see like a mixture of liquid and solid within if you're at a temperature and pressure along that line here, or along this line, right? You'll see liquid and gas existing at the same time. There's a couple special points that you need to know. First is the triple point. And this is where all three states exist in equilibrium. So let me see. Okay, so there's that definition here. And then we also have this place called the critical point. And this is where after that temperature is hit or that pressure is hit, so let's say, so this is like the temperature and pressure in which the gas can't go back to liquid. So if we're at this temperature here, it doesn't matter how high or how much we increase the pressure, it won't go back into the liquid phase as long as we're at this critical temperature. So I'll write that down. All right, so that's the definition of the critical point there. The temperature and pressure that a substance will stay in the gas phase, and increasing pressure at that temperature can't take it back to liquid. But of course, if we then drop the temperature back down, then it can go back into liquid. It's not stuck in gas forever. All right, so those are what phase diagrams are.